Uh, Good morning once again. This lesson is brought to you by Yaka, and it's one of our online packages that we offer. Remember, this package is well explained in the engagements that we are having with you and your parents. So remember to attend these engagements every time they are announced together with your parents so that you can know exactly what we offer, and that will be helpful for you in making a decision to continue this relationship that you have with us. Last week we looked at something interesting, something about structures of substances, and some of you were like, these things are too simple. In fact, they're even boring us. We want something more interesting. And I want to always remind you that at Yaka, it is a self-paced learning. Anything that you want to learn is what we shall teach. Okay. Where you have a problem is where we tackle. Where you have challenges is where we try to solve. Okay. So therefore, when you guys mentioned that, I asked a couple of you, what would you love to learn? What wouldn't bore you? And most of you said moral concept, right? And I was like, okay, I'll take that as a challenge and organize for you a lesson about moral concept, at least the introductory lesson, for you to understand where morals come from, how do we calculate them, and things like that. So that's what I've prepared for you today about molds. Pretty sure that will make many of you very excited because you suggested it. All right. So without further ado, I'll go ahead and introduce to you molds or the mole. And it's what we shall look at today. Okay. So we shall try to look at where the mole comes from, how to calculate moles of a single substance, and also we shall tackle a little bit about reacting mass calculations. The first three in the contents here is what we shall look at mostly today. The rest we can always look at as we continue this wonderful relationship. So the mole, many of you have heard the word, many of you have used it, many of you have had tales about it since when you were probably in P7 vacation. You've heard about the mole. Today, I would love for you to leave this class when you have understood what exactly the mole is and what we use it for, and some calculations on how it is utilized. Some of the things that you will need to know today is how to balance simple equations. So you need to have that in mind already. If you've forgotten how to balance equations, you need to channel that right now. It will be very, very, very important. And how to rearrange mathematical formulae. Rearranging mathematical formulae like cross multiplication. When do you cross multiply? When do you make one a subject? Okay, things like that. That's what I want you to channel and be able to remember in this lesson. Now, who can tell us, what do you think a mole is? You can raise up your hand and tell us what you think, what a mole is. Giovanni, don't write on my screen. I said, just raise up your hand. I'm trying to see who is going to raise their hand. What do you think a mole is? Has any one of you ever heard of the term mole? And if you've heard of it, What do you think it is? Just tell me what you think. It doesn't have to be the most correct answer you have ever given in your life. Ned, just tell me what you think. Anyone? Stella, what do you think? Okay, Albert. Yes, Albert. Unmute your audio and speak, Albert. To unmute, you just swipe left and then tap in your screen, you'll see it. As Albert figures that out, Giovanni.
A mole is the amount of a substance that contains 6.02 times 10 power 3 particles.
Okay, that is good. That is good. That figure, it is not exactly power 3. You missed out. It is power. It is a huge figure. It's power 23 actually. So that's a good explanation. The number of particles in a substance, that total to 6.02 times 10 power 23. It's a huge number. That's good, Giovanni. Good job. Albert, did you want to try?
Yes.
Okay.
This is a quantity of particles in a substance.
Quantity of particles in a substance. That's also a good explanation of what a mole is. Good job. So I see you have an idea about what a mole is, and that's good. That's gonna help us in today's lesson to learn exactly what it is and why we need it. So, like I've asked you what a mole is, and here is my simple explanation of what actually a mole is. Okay. A mole is the standard unit of amount of a substance. It's a standard unit of amount of a substance. Okay. A standard unit is that unit that does not change with time or location or anything like that. Okay. So the amount of moles in a substance always stay the same, whether you're on Mars or you are on Earth. Okay. So it's a standard unit that we use to tell the amount of substance, just like the two of you have mentioned, Albert and Giovanni. Now, one thing you have to note is that this is just a number, okay? It's just a number, but it's a very big number, like I had mentioned before, okay? It is a way of saying a number in words. So we use a mole to represent a number. Instead of always saying that number when you are referring to a mole, we don't do that. Instead we just say, oh, it's a mole, 1 mole, 20 moles, instead of saying that number all the time, okay? For example, sometimes when you guys want to say 12, instead you say a dozen, right? It's the same thing here with the mole. Instead of saying that number, we say a mole, okay? Sometimes when you want to say 20, you just say, oh, that's a score. When you want to say 144, you say, oh, that's a gross, okay? So same thing, that's the way, that's the sort of the origin of using the mole. We use it to refer to that number that we shall know what it is. Okay, Giovanni mentioned it a little bit. We shall go into details of what it is later. All right. So here we go. How big is this number? It is right there. If you can read this number, good for you. This right here. If you can read it in words. So every time you say more, this is what you're saying. Every time you use the word more, this is exactly what you're saying. Okay. Can you please turn off your audio? Who is that? Okay, your audio is off. Great. So every time you say mole, this is the number you're saying actually, in actual sense. It is that big. But for us to make it easy for ourselves, mathematicians just say, let's make it in terms of multiples of 10. And when you do that, it is 6.022 times 10 power 23. So someone had messed up with the 23 and said it is power 3. It is not power 3, it is power 23. Okay? So 6.022 times 10 power 23. That is the mole. That is the number we always say, okay, when we are referring to a mole. So instead of always saying, oh, 0.022 times 10 power 23 is contained in this mass of sodium chloride. We don't say that. Instead, we say, oh, 1 mole of sodium chloride is contained in this. Okay. That's what we say always. Instead, we use 1 mole for us to make it easier for ourselves not to always pronounce that number. So that's the mole. That's why we refer to it like that. Okay. This is also known as the Avogadro's number. Okay, Avogadro was a person, a scientist who discovered this, and we use it as a standard unit. Now, it doesn't matter the number as long as everybody sticks to the same value. So in the whole world, every scientist, including you now, we use this number. It is for us to stay consistent and not really for everyone to have their own number. That would mess up the values that we calculate for each substance. Okay, so consistency is key here. Now, why should we use a mole? Why should we use it? You see, atoms and molecules don't weigh much, so it is easier to count large numbers of them. In fact, it is easier to weigh substances. All right. So when you look at atoms and molecules, it is hard to really know how much they contain, because they don't contain much, right? So counting their number is not as easy as just weighing the substances themselves. So we count a bunch at once instead of concentrating on just a few, or just a few molecules or atoms. Now, using moles tells you how many particles you get in a certain mass, the mass of a certain number of particles. So that's what moles tell us, okay? The number of particles, okay, you can get in a certain mass, okay? So in other words, the mass of a certain number of particles of that substance. Okay, so for example, if you have a certain mass of sodium where you want to find the moles, when you're finding those moles in that mass, you're finding actually how many particles they contain. Okay, those are the moles. Again, what you need to know is balancing equations. Okay, if you don't know, keep trying to balance those equations. You get them. Okay, you get them. But in this particular segment today, you really need to remember balancing equations, and you will see why. So far that is the mole. Okay, so far that is the mole. A small summary here. We have said it's a standard unit of amount of substance. It's a standard unit, like just like a meter, just like a dozen or a gross. And we have said that it is a big number. And the number we have given it, it's right there, Avogadro's number, 6.022 times 10 power 23. Okay. It is the number that every scientist sticks to for consistency. We use it so that we can find because atoms and molecules don't weigh much, so it is easier to just count large numbers of them. In fact, it is easier for us to weigh them. Using moles tells us the number of particles in a certain mass of a substance. Okay, so far that's what we've looked at on what a mole is. Now, I need questions of what you've not understood about a mole. Questions? What you've not understood about the mole before we move forward? Any questions so far? Okay, I guess everyone now understands where the mole comes from or what a mole is, right? Okay. Now, let's go ahead and see how we can calculate the mole, okay? Calculating the number of moles of a single substance. How do we do that? How we do that, we use this formula here. This formula tells us how to calculate moles, okay? So moles is equal to mass divided by molar mass, okay? Mass divided molar mass will always give you moles. Shall see how we calculate molar mass if you've forgotten. Mass, the mass of a substance, you can always weigh it. Whatever mass you have, you just use a weighing balance and we measure. That one is easier, okay? Now, when you rearrange this, you can utilize it to find each of these species or whatever. You just make one the subject. For example, we know that moles is equal to mass over molar mass, like we have said here. If you want to get mass, right, you just cross multiply. Like I said, you need to know these skills, okay? Just cross multiply if you want mass. So you have mass as a subject, which will equal to moles multiplied by molar mass, right? And then if you want molar mass, okay, you just make molar mass the subject and you have mass divided by moles. That's it. That's how you rearrange. Now, the easiest way to remember this, the easiest way that you can use is this right here. This triangle you see here. If you always draw this triangle, it will help you. So in this triangle, you have mass up, okay? Then moles multiplied by molar mass down, right? If you want to find any of this, you just cover it up. So for example, if I want to find mass, if I cover up mass, because it's what I want to find, you'll find out that mass is equal to moles times molar mass, which we have seen here, right? And then if I want to find moles, I'll just cover it up again. You cover it up in the triangle, you'll see that you have mass over molar mass, okay? Then what if you want to find molar mass? Again, just cover it up. This is why this triangle helps. And you have mass over moles, okay? That's the use of this triangle. If you do this triangle, it will help you remember this formula very well, regardless of whatever you asked for. Okay, any questions on this? So let's talk about the units. We know the units of mass is grams or kilograms. The units for molar mass is grams per mole. Okay. Remember the formula for molar mass is mass over moles. So if it is grams, because that's the unit of mass, then since moles are down, you use per, okay, to represent that those moles are down, which is right here anyway. I'll do myself. It is right there. Okay, so grams per mole or kilograms per mole. as the units for molar mass. Where they come from, I've showed you. Molar mass is equal to mass over moles. So the moles are down, meaning when you write the unit, it will be grams per. The per means that division there. Okay, per mole. That's it. That's where the units come from. Questions here? Is there anything that you're confused about? I want you to ask questions so that you don't go out there in the group and say, hey, I didn't understand anything today. No, if you don't understand, ask now, okay? Ask now so that everyone else can get a better explanation of whatever you have asked. It might not be only you. Okay. Please, if you feel like you can't talk, or you can always type the question in the chat box right there. All right, let us continue with this and see some examples of calculations. So we have a question here. Calculate the number of moles of oxygen molecules in 4 grams. Now, who can tell us the first thing that we need to find here, or the first step that we need to do on this question? You are given the element or the substance that they need you to calculate its moles. Okay, it is oxygen. They have given you the mass. They want you to find the number of moles. We already have a what? A clue here with our triangle. So what is the first thing that you do when you have such a question? Okay, Peter Emma says, find the molar mass. Peter, that is correct. The first thing that we do is find the molar mass of the substance we're given. So we need to find the molar mass of oxygen. How we do that is we have the formula for oxygen, which is O2, meaning 2 atoms of oxygen. Each atom of oxygen weighs 16, okay, 16 grams. But we have 2 atoms, therefore we multiply by 2.
Teacher.
And yes, please. Are you asking a question? Someone said teacher and then went away.
Teacher, where does the 16 come from?
Oh, where does the 16 come from? Good question. Okay, good question. Who can tell us where the 16 comes from? Yes, Hamira?
16 is the relative mass of oxygen.
Okay, the relative mass of oxygen. Now, the other place you can find this 16 is where? Who can tell us where we can find it easily for someone to get it?
Periodic table.
Yes, Hope is right. When you go on the periodic table, you'll find a value that is most times the value has decimal places, but the word relative eliminates decimal places, so we don't use decimal places here. Just take the whole number. Okay, so an atom of oxygen weighs, okay, this, right? That is its relative mass. When you have 2 atoms, you multiply by 2. Okay, you multiply by 2, and that gives us the relative mass, molecular mass. Now this one becomes molecular mass or molar mass. Okay, we can use that interchangeably. Okay, this is a molecule now, so the relative molecular mass will be 32. So our molar mass is 32 grams per per mole. Now that we have our molar mass, what else do we do now? Who can tell us the next step that we'll move on to? What is the next step? Who knows? Yes, Hope?
We are going to list the formula.
Yes, we substitute into our formula. We already have our formula there. Moles are equivalent to mass divided by molar mass. Since we already have the molar mass now, and we were given grams, the mass in the question, so just get the mass over the molar mass, okay? And you get the answer. The answer is there, mole. Where we get the units of this, you've seen that we're dividing grams. These units always help us. If you divide with the units, you always know the end result. So we have grams and grams here, right? That will make us remain with per mole. But this per mole is under the division sign. So when you get the answer, you just get the reciprocal of per mole. The reciprocal of per mole is just mole. Okay, it's like the opposite. That's why I said you need to know mathematical formulae before we tackle mole concept. So if you're good at mathematics, you already know what this means when it's under a division sign. Once it comes up, it becomes the opposite, which is just mole. It's no longer per mole, it's just mole. So that's the answer right here, 0.125 mole. Those are the number of moles in 4 grams of oxygen. Any questions? Mole, not moles. We use mole as the unit. But when you're mentioning it in first principles, you can say 0.125 moles. When you're just mentioning it as an SI unit, you just say mole. Not mole with E, mole without E. So I'm replying to Bridget, who typed in the chat box. I hope that is clear. This is the SI unit. When you're mentioning it in first principles, it is easier for you to say 0.125 moles, right? But the SI unit remains just mole. All right, good job, Bridget. So that's it. Any questions here? That's a very good question to help us understand how to calculate moles. Okay, another example that we can have is right here. Now here we have been given the moles. We have been given the moles. We have 0.25 moles. You realize now I'm saying 0.25 moles instead of just saying 0.25 mole. Okay, so when you're mentioning it in first principles, you just say moles. But the SI unit, you have to know it at the back of your mind that the SI unit is just mole. Okay, so 0.25 mole.
Sir, I've not understood.
Okay, where?
There, where the what? The calculations.
Oh, so let's do this one, number 2. Then you'll ask whether you have not still understood. Okay.
Okay.
All right. So we have number 2 here. If you've not understood number 1, number 2 will help us understand number 1 better. All right. We have a question here. What is the mass? So now they are no longer asking for moles. We have been asked to calculate mass. We have been given the number of moles, and we have the formula of the compound. Been given the formula of the compound. This is sodium carbonate. Sodium carbonate. Okay, now what do we do first? Who knows what we do first here with what we've been given?
You get the relative mass.
Okay, we need to find the relative molecular mass of sodium carbonate. That is correct. We need to find the relative molecular mass of sodium carbonate. That will help us find the mass that they want. Okay, so here we go. To find the relative molecular mass of sodium carbonate, we just have to know the formula, which is right here, right? That's the formula of sodium carbonate. And then we need to know the masses, the molecular masses of each, okay? So the relative molecular mass of sodium, in fact, the relative atomic mass of sodium is 23, okay? It's 23. In sodium carbonate, we are seeing 2 atoms of sodium. Therefore, we multiply by 2, okay? Remember, we talked about where we get this figure. This figure is found on the periodic table. These masses are the masses that were used to arrange the periodic table the way you see it by Mendeleev, okay? Mendeleev used these masses of atoms to rearrange the periodic table the way it is. So it is important for us to know these masses, right? And they are written on there. Do we cram these relative masses? Are they provided? You need, in case of the question, they will always provide them, but the more you calculate them, the more you'll get used. You no longer even need to cram them. The more you do these calculations. Also, the more you go back to your knowledge of the periodic table, the more you will understand these, okay? So, therefore, we see that 23 is our mass of sodium, the atom of sodium. And we have 2 atoms, so we multiply by 2. The other atom we have is carbon. Carbon, its mass is 12, okay? So we just add that on. We add that on. And then we add the mass of oxygen. Oxygen, remember, we have already seen the mass of oxygen before. It is 16. But in this compound, we have 3 atoms of oxygen. So therefore, we are going to multiply by 3. And the relative molecular mass of sodium carbonate will be 106. 106 is the relative molecular mass. Remember, relative molecular mass doesn't have units. When you include the units, that no longer becomes relative molecular mass. It's no longer relative, okay? It is now just molar mass. All right, so the difference is there. When it's relative, it means you've just averaged the different isotopes or the different atoms in that particular substance in terms of their atomic masses, all right? And those don't have units. When you change it into molar mass, then you have to have units, which are grams per mole, okay? So it's important for us to remember that. Okay, good job, those who are typing in the group. All right, so now that we know the relative molar mass of sodium carbonate, which is 106 grams per mole, I've calculated it from this. Let us see what we do next. So now that we have our molar mass, we have our moles here, then just substitute into the formula to get our mass. So remember, mass, you just have to cover it. You see this triangle? Mass is covered. When mass is covered, we see that what we have to do is multiply the moles to the molar mass, which is what we're doing here. So 0.25 which you were given in the question as the moles multiplied by the molar mass 106 to get 26.5 grams. Someone had already calculated that in the chat. So someone is very, very active in the chat here. That was Joe. So Joe, well done. The answer that we get is 26.5 grams, which is fair. All right. Now, there was someone who said that they didn't understand the calculation. How far are you now with catching up with this calculation? Are you still confused? I don't remember who that was.
Somehow.
Are you someone there? Okay, the more we calculate them, the more you get them, okay? But in case you have something specific you have not understood here, please ask. And then we can repeat and see how to move forward.
Excuse me, Tia Solomon.
Yes, please.
Are these learners sending their names and contacts to the team?
Did you instruct them to send them? I'm not sure.
I think Patricia is here on the call. She should have communicated.
No, no one has communicated that.
Okay, learners, you send your numbers and names in the chat as you continue with the lesson. Thank you.
Okay, so you've heard that. As we continue, type in your phone contact or email with your name in the chat, okay? As we continue, you can be doing that. So that is the calculation. Any questions here? Any questions on how to calculate number of moles using our formulas? Where is the 12 coming from while finding the relative molecular mass of sodium carbonate? Who can tell us where the 12 is coming from? That's a good question, Hope. Where is the 12 coming from?
From the carbon dioxide.
Hey, carbon dioxide, Explain further. Okay, Peter, Emma, tell us. Peter, unmute your audio and speak. Oh, we didn't get you where probably your network. Okay, we can't get you. We can't get you. Maybe you can type it in the chat. So, someone has answered your question. Albert has answered your question in the chat. So check the chat and see. Albert says carbon has relative atomic mass of 12. And it is correct, okay? The relative atomic mass of carbon is 12. That's why we are adding it there, because it's part of the atoms in sodium carbonate. Okay. Hope, do you get that now? Where the 12 is coming from?
Yes, sir.
Okay, good job. Remember to write your name and contact in the chat box. Any other questions? Any other questions? Okay, well done. Let's continue. And so those are our calculations. Now we have another interesting calculation here. We're moving on to reacting masses or reacting mass calculations. So here in reacting mass calculations, we deal with reactions. You're not just given a formula or a substance to find its moles or mass or molar mass. No, here you're using equations because we are in reactions. Okay, you're using equations to calculate these. Now, this is exactly what you do in most of your practicals, right? And it's where we're moving now. Okay, so this is what we do. We have a very nice reaction here. This reaction is about calcium carbonate reacting with hydrochloric acid, forming calcium chloride, carbon dioxide, and water. Okay, that is our reaction. All right, now, these are some of the questions you could be asked to find, and there are sample questions here to help us calculate them. Okay, so the first thing, let's look at number one. If you are asked what is the relative formula mass of calcium carbonate, okay, so we have the formula of calcium carbonate there. And for us to be able to find its relative molecular mass, we just have to know the atomic mass for calcium, which is 40. Okay. And then for carbon, which you have seen in the previous question, and help us the question about it, it is 12. Okay, remember you can always find these on your periodic table. You just round off to the nearest whole number to find them. You round off those masses on the periodic table to the nearest whole number to find these relative atomic masses. So that one of carbon is 12. The one for oxygen, we have seen it now a couple of times, it is 16. But we have 3 atoms of oxygen, so we multiply by 3. The answer we get here is 100. So this is our relative molecular mass, okay, which is great. Salma, you're asking what's with the numbers. Please type yours there also, your name and your contact. Your name and your contact. Peter, find a good network. Guys, if you can't hear me, you type in the chat box that you can't hear me, but I'm pretty sure most of you can hear me. So Peter, try to find a good network. Okay. So far, we have found our relative molecular mass, okay, using just the formula of calcium carbonate. The other thing that you can be asked to calculate is what is the mass of 1 mole, okay, the mass of 1 mole of calcium carbonate. From our definition of 1 mole, we can see that when you find the relative molecular mass, is always equivalent to the mass of just 1 mole of that particular substance. Okay. So here it would be 100 grams. Since you have already calculated the molar mass here, it would be 100 grams. The other question you can be asked is how many moles of hydrochloric acid react with 1 mole of calcium carbonate. Okay. So that's when you have to know balancing equations. Your equation has to be balanced for you to know this. We can see on the equation that 1 mole or the reaction ratio is 1 to 2, meaning 1 mole of calcium carbonate reacts with 2 moles. Okay, the balancing figure here is 2 moles of hydrochloric acid, right? So therefore, if you ask this, you just have to say that, okay, 1 mole, I mean, this is number 3. 1 mole of calcium carbonate reacts with 2 moles of HCl, right? Just from the equation, okay? So if you want to ask, where is the 2 coming from?
Yes. Yes.
I knew you were going to ask that, right? So if you ask where the 2 is coming from, it is here in the balancing, okay? When you look at this balancing, there is a silent one here. We always don't write the ones while balancing equations. I guess you know that. But we have a 2 on hydrochloric acid, meaning 1 mole of calcium carbonate reacts with 2 moles of HCl just from our balancing right here, okay? Can you see that? That's where it is coming from. That's our reaction ratio. That's where we get the 2 moles. Does that make sense now, where it is coming from? Okay, good. Please share your contacts in the chat box before we finish this lesson. Bridget, Jackie, Peter, Singer, Sam, Brave, Malach, Yvonne, share your contacts in the chat box. Write your contacts there. So now you know the reaction ratio, how we use it, and how we get the number of moles that are reacting. It is right there, and we have got it from this place here. Okay. Number 4, how we can get this. What is the relative formula mass of HCl? This one is very easy. Okay. The relative molecular atomic mass of chlorine is 35.5. And that of hydrogen is 1. So therefore, the relative formula mass will be 36.5. 36.5. Okay, so that one is easier. And then what is the mass of 1 mole of HCl? What is the mass of 1 mole of HCl? Again, from our definition of a mole, we know that that will always be equivalent to the relative molecular mass, which we have already found, and it's right there. All right. So I've been going so slow so that you can pick up every single detail that I'm explaining. What mass of HCl will react with 1 mole of calcium carbonate? What mass of HCl will react with 1 mole of calcium carbonate? Now that one, this question takes us back to our ratio here on number 3. Okay, on our ratio right there, that 1 mole of calcium carbonate reacts with 2 moles of HCl. So if they ask for what mass of HCl, remember 2 of these HCl, 2 molecules or 2 moles of this HCl are reacting. And if 1 mole of HCl weighs 36.5 grams, then, okay, the reacting ones, the 2 moles will weigh just 2 multiplied by this, which is 2 multiplied by 36.5. Right there, which gives us 73. Does that make sense? Is anyone confused there? Anyone confused where why we multiply by 2 is from our reacting ratio, that 2 moles of HCl are reacting, but we have seen the mass of 1 mole is there. So what about 2 moles? Just multiply this by 2. You get the mass of 2 moles. Okay. And lastly, what mass of carbon?
What is the relative atomic mass? Or
Pardon your question?
excuse me.
Yes.
What is the relative atomic mass of chloride?
The relative atomic mass of chlorine is 35.5. It is right here. Let me circle it again with a different color. Right here. We're calculating the relative molecular mass of HCl, and we used 35.5 as the relative atomic mass of chlorine. Okay. The one for hydrogen is 1. So the relative molecular mass of HCl, the answer was 36.5. Someone else had a question?
Yes.
So lastly, the mass of carbon dioxide produced. So moles of carbon dioxide are all equivalent to the moles of calcium carbonate. Okay, the product ratio is 1:1. When you look at the equation, this is why you need to know how to balance equations. 1 mole of calcium carbonate produces 1 mole of carbon dioxide. Okay, there's no any number here, 2 or what, there's a silent 1. So the reactant to product ratio is 1:1, right? So therefore, it means that the moles of calcium carbonate will be equivalent to the moles of carbon dioxide formed. So moles of carbon dioxide will be 0.001 moles, and the mass of carbon dioxide will be 0.001 moles multiplied by
Excuse me, teacher, I didn't.
mass. Yes, please.
I didn't get number 6.
Number 6. Number 6, I've explained that you just multiply the number of moles of HCl reacting at 2. 2 HCl react with 1 calcium carbonate. Therefore, if you ask for the mass of HCl, you already know the mass of 1 mole of HCl. It is right there. Just multiply it by 2 to get the mass that is reacting of HCl. Remember, there are 2 moles of HCl that are reacting. So that's why we multiplied by 2. Okay. And lastly, yeah. So you get moles from our formula that we looked at. Moles multiplied by the mass gives you, multiplied by the molar mass gives you the mass of carbon dioxide that was formed. Okay.
Excuse me, sir.
So,
Can you repeat number 7?
Number 7, quickly, again, we have seen the reactant to product ratio is 1:1. 1 mole of calcium carbonate forms 1 mole of carbon dioxide. Remember, we are finding the mass of carbon dioxide produced. So 1 moles of carbon dioxide are equal to moles of calcium carbonate. So the product reaction to reactant ratio is 1:1. And we know that the moles of carbon dioxide in this case would be 0. Have the mass of calcium carbonate. Okay, mass of calcium carbonate, and we already have the molar mass, which we can find very, very quickly, and then the moles are found. Okay, the moles will be equivalent to that. Then to find those of carbon dioxide, just multiply it by its molar mass and get the answer. We shall continue from there this time, next time when we meet next week. So just don't worry, I'll repeat this for you to get it even better. All done for today. Good job. I'll see you next time.
44.
The 44 is the molar mass of carbon dioxide. You can find it on your own. Okay. You have seen how we find molar mass. So 12 plus 16 times 32. We have been calculating that. Take it there. Okay, good job, everyone. We'll start from there next time. I hope you have picked up something today. All right, you're welcome, Elisha. See you next time.
Thank you, teacher.
You're welcome. See you. We'll calculate more next time.